Okay, last but not least, here we go. Find the indicated sum of this series. It's an infinite series, right? And if we're going to find an infinite sum, this has to be a geometric series where the numbers are getting smaller. Are these numbers getting smaller? Yes, they are. Okay? So we see that they're getting smaller. We're guessing at this point that this is geometric. The only way to know for sure is to divide backwards, right? Negative 5 over 32 divided by 5 over 8, right? So this is negative 5 over 32 times 8 over 5. And if you do a little presto changeo here, you're going to get negative 1/4, right? And in the interest of saving time, just take my word for it. If you divide this by this, we get negative 1/4. If you divide this by this, what are we going to get? Negative 1/4. So we have our common ratio. Okay? The absolute value there is between 0 and 1. That's what we talked about. We need the common ratio to be between 0 and 1. It's absolute value. So we have R, and we have the first term. So the sum here is the first term over 1 minus the common ratio, which is 10 over, what is 1 in terms of fourths? 4 fourths? 4 fourths minus a negative 1/4 is 5 fourths. And we've done this how many times on these examples? We take the denominator of the denominator and multiply it times the top. Sorry, I ran out of space here. So we end up with 40 over 5, and 40 over 5 has a value of 8. So the sum of this series is 8. The reason I can do this is because it's geometric and the terms are getting smaller. So remember, that infinite sum is going to be negligible as we reach, towards the end of this infinite sum. The numbers are so small they don't affect things. But we started this thing off by taking 10 and subtracting 2.5. So after the first two values added together, that was 7.5. Then I added a little bit more than a half, so I went a little bit past 8. Then I subtracted it. So I'm kind of bouncing on either side of 8. We get this sort of convergence on this value of 8 to get this infinite sum.